We're continuing on in Chapter 13 about matrices and determinants, and we're going to calculate the inverse of a square matrix. This is 13.6a. There's 14 previous videos that are linked in this description in case you get lost or confused. So remember the three-row equivalent operations we learned in video 13.1b? Multiplying a row by a constant, exchanging two rows, adding a multiple of one row to another. And remember, there's no single correct sequence of steps when calculating an inverse. We may find the inverse using a different number of steps or different order, right? But there's only one correct answer. So you could follow along with me and do it in a slightly different order and still get the right answer. We can calculate the inverse of any square matrix. Remember, it's square, which is with the 2 by 2 matrices exists only when the determinant of the matrix is a non-zero, okay? It's got to be a non-zero. We want to find the inverse of this matrix. This is matrix A. So remember, they're labeled with a capital letter. The first thing we do is we write matrix A and insert an identity matrix. Remember, identity matrix has ones coming down its main diagonal with zeros above and below it. We insert this identity matrix to the right here and we're going to change our original matrix into an identity matrix, and we're going to have our inverse end up over here when we're done. So what we do is we make a large matrix with an identity matrix of the same size to the right of our original matrix, all right? Now we're going to perform row operations, and we learn how to do that in 13.1b. We do it until the elements on the left become an identity matrix, and the elements need to show there's going to be a diagonal here of all ones with zeros above and below it. When we're done doing that, the elements on the right are going to be our inverse matrix, and we're going to have an identity matrix on that side. That's our goal. So we need to get the zeros below this 1, this negative 3 and 2 need to be zeros. Okay? So the first thing we're going to do, just like in a system of equations, we're going to try to create additive inverses, zero pairs, to eliminate them. So to make this negative 3 a 0, we can multiply everything in this first row by a 3. That 3 with that negative 3 is going to create a 0 here because of additive inverses. So we get a 3, a 6, a 12, a 3, a 0, a 0. We add it to this red row, and we get a 0, 1, 6, 3, 1, 0. So now that spot's a 0, okay? Now we go back to the original one, back to the original matrix, and we multiply everything in row 1 by a negative 2. If we multiply everything in this original row by a negative 2, that 1 is going to become a negative 2, isn't it? And that's going to make that positive 2 a 0. So that's what we do. And we copy our red row and our blue row and our green row. We're going to multiply everything. And remember, this is our new red row, isn't it? The 0, 1, 6 is a new red row, all right? So we've got our original blue, our new red, and our original green. We're going to multiply everything in the original blue row by a negative 2, and then we're going to add it to the green row. We get a 0, negative 7, negative 44, negative 2, 0, and a 1. And that's going to make that positive 2 into a 0. See? We still need to turn these into zeros, that into a 1, and those into zeros to get our identity on this side, don't we? Now look at this spot right here, this 1 with the black circle around it. We just got lucky. There's a 1 in that row 2, column 2. That's a lucky coincidence. If it didn't fall as a 1, we would have had to have divided this entire row by some number to make that a 1, because that's our goal, is to have all 1s coming down with zeros above and below it, right? So now we want zeros above and below this 1, okay? And that's in this spot, second row, second column. So if you remember from video 13.1a, that's how we can identify where the elements are. When you see the little 1, that's the first row, and that's the first column. So that's the second row, second column. That's the third row, third column, okay? So we want zeros above and below this 1. The 2 and the negative 7 need to turn into zeros. So we can multiply row 2, because there's a 1 here. We can multiply it by a negative 2. That'll get rid of that one, won't it? That'll turn that into a 0. So we do that. We multiply everything in this red row by a negative 2, and we get a 0, negative 2, negative 12, negative 6, negative 2, negative 0. We add it to our original blue one, and we get a 1, 0, negative 8, negative 5, negative 2, and a 0. We want that to be a 0 below the 1, so we can multiply this by a 7. to make additive inverses, can't we? So we multiply everything in the red row by a 7, and we add it to the green one. That's going to become a 0, 0, negative 2, 19, 7, and a 1. So now we end up with this as our new matrix, and we've got a 1 and a 1, and 0, 0, 0, and a 0 above it. We still need to do these, don't we? That negative 8 and 6 need to be zeros, and that negative 2 needs to be a 1. So we're almost done. We want to turn that negative 2 into a 1. So what we do is we multiply everything in the green row by a negative 0.5. That'll turn that into a positive 1 because the two negatives, right? It's the same thing as dividing by a negative 2. We multiply everything in the green row by a negative 0.5, and we're going to get a 0, 0, 1, like we wanted, negative 9.5, negative 3.5, and a negative 0.5. So now that's our new green row. We still need these to be zeros. So we can use the green row, multiply it by an 8 to make additive inverses right here with an 8 and a negative 8 to make that a 0. So we multiply everything in the green new row by an 8, and we get a 0, 0, 8, negative 76, negative 28, and a negative 4. We add it to the blue row. That creates that 0 pair there, and now we have a 0 in this spot. Negative 81, negative 30, negative 4. We still need to get rid of that 6 and make it a 0. So we can go back to this green row and multiply it by a negative 6, which will turn this 1 into a negative 6, which will make that a 0 pair, won't it? So we end up with a negative, we end up multiplying the green row by that negative 6, and we get a 0, 0, negative 6, 57, 21, and a 3. And when we add it to that red row, all right, to this row, we get a 0, 1, 0, 60, 22, and a 3. So now, remember our goal was to have all ones coming down the diagonal and all zeros above it and below it. We did it. Now we have a 3 by 3 identity matrix on the left, right here, and a new 3 by 3 matrix on the right. And the elements of the right side matrix form the inverse. It's the inverse of A. And here's our identity. We slowly turned each one of these into a 1 and the ones above it and below it into zeros, and it became an identity matrix. So we did it. Here's our original matrix A, and here's the inverse of A. Okay? Now this whole thing wasn't difficult to do. It was just long and drawn out. All right? So the multiplication and addition and everything was very easy. It's just there was a lot of it. And anybody who's done a system of 3 equations can tell you, yeah, there's a lot of elimination and substitution, isn't there? Our next video is 13.6b, and we're going to talk about how to solve a system with the inverse of a matrix. Like I said, I'm going to have those 14 videos linked in this description to help you out in case you need to do any review or pick up on something you've missed. I'm going to add this to the Algebra II playlist. So just remember your goal. Your goal is to write one big matrix and slowly turn these into ones on the diagonal and zeros above and below it, and change it into the inverse on this side and identity on that side, okay? I'm really proud of you for making it this far. We're almost done with Algebra 2. You're doing very well, okay? Have a great day, and I'll see you next video. Bye.